Welcome to the Onveos podcast, where we share actionable insights on web design, SEO, paid advertising, and AI automation. Each episode is focused on practical strategies you can apply immediately to build smarter systems, attract better traffic, and scale your business with confidence. Today, we're really taking those ideas, smarter systems and scaling, and pushing them to their logical extreme. We are doing a deep dive into AI agents.
Right. These autonomous systems that can handle complex workflows, make decisions all on their own.
Exactly. And our mission today is to get past all the hype and really look at the sources because they detail both these spectacular commercial upsides. I mean, we are talking hundreds of millions in
That's
savings.
great. Yeah.
It is.
Yeah.
But we're putting that right up against the severe, very specific, and often hidden security vulnerabilities that, well, decision makers just have to address right now.
And that juxtaposition, that's really the core tension of this deep dive. The sources we've pulled cover, well, everything from how companies are getting these record-breaking efficiencies to how the very architecture of these agents is completely changing user interface design.
Okay.
But crucially, we're also going to dissect, these architectural assessments of popular open source agents, and they reveal these really specific attack vectors like prompt injection that are classified as critical severity risks.
So we're unpacking this whole new operational standard. We're looking at how these agents use that sense plan act loop, celebrating the massive value they deliver, and then immediately turning to analyze the, well, catastrophic risks they introduce when they're let loose on the open web.
Let's get into it.
Okay, so let's start with the basics, right at the foundation. What exactly is an AI agent? Because we're way past simple macros here.
Oh, way past.
Yeah.
We're talking about systems that use machine learning, natural language processing, to really understand complex goals. They learn from their environment and then, autonomously execute these multi-step actions to get a task done.
And that word autonomously, I mean, that's really doing a lot of the heavy lifting there, isn't it?
It is. An agent is, it's perpetually in this iterative feedback loop. You can break it down into 3 stages. First, it has to sense the current state.
So reading a web page or maybe an API.
Exactly. Or analyzing a user's prompt. Then it enters the reasoning phase, where it has to plan the next logical action. It breaks the big goal down into smaller executable steps. And finally, it acts.
It clicks the button, it types the text.
Right. Or it calls a function. Then it senses the new state, and the whole cycle just repeats and repeats until the goal is achieved.
That sounds like a very technical description for a really smart intern.
Right.
But the real-world business impact is just staggering. We're seeing numbers that, traditional software just couldn't touch.
No, they couldn't. The case studies are phenomenal, really, because they show this optimization at a massive scale. Look at UPS in their agent, Orion. It's focused on route optimization.
Which is incredibly complex.
It's not just point A to point B. Orion is constantly optimizing thousands of variables. Traffic, delivery windows, fuel costs, what's in the truck, driver breaks.
The fact that it's saving them $300 million annually, cutting 100 million miles, and reducing emissions by 100,000 metric tons.
Wow.
It just proves these systems are finding efficiencies that, a human planner or even older algorithms just could never find. They were invisible.
That kind of overhaul usually takes years. To do that with dynamic decisions is remarkable. And I'm just as impressed with how they're scaling, human expertise.
That's where customer service agents are just, well, they shine. Take Ruby Labs. Their agents are handling 4 million support chats a month. 4 million. And they resolve 98% of them without a human ever getting involved.
98%. And it's not just cheap, fast service. The agent is smart. It can flag a user who might be about to cancel and offer them a targeted discount right there in the chat. That one move saves them an extra $30,000 a month.
So it turns a cost center into a retention engine.
Precisely. And we see it in lead qualification too. The Waiver Consulting Group, they brought in a bot called Waverlin. They saw a 9 times increase in visitor engagement and a 25% boost in client consultations.
Because the agent is filtering out the noise.
It's filtering out all those dead-end leads. So the human sales reps, they only spend time on high-conversion prospects. It's just a smarter way to work.
And even in an industry as fast as retail.
Especially there. Zara uses an agent to scan social media, shopping data, all in real time. It spots emerging trends instantly, and that directly led to a 7% increase in sales between sometime in 2023 and sometime in 2024. So these agents aren't just for efficiency, they are becoming critical for, real-time market strategy.
Okay, so if these systems are so good at making decisions and taking action, it really begs the question, why are we still stuck clicking through static, complex interfaces that feel like they were designed 50 years ago?
Exactly. I mean, all this success in optimization, it points to a fundamental change in how we're going to interact with all software. We've all felt that pain of feature creep.
Oh, yeah. Where the one thing you need is buried under 5 menus.
Yes. And valuable tools get hidden behind all these buttons and complex navigation. The sources say e-commerce alone loses something like $18 billion a year just from abandoned carts, often because the navigation is just so clunky and frustrating.
That is a huge price tag for bad UX. So you're saying these AI agent-driven UIs are the fix, moving us from a static map of buttons to more of a dynamic assistant.
That is the shift. It's about human-centered AI. Instead of making you, the user, learn the app's fixed structure, where to click, what menu to open, the agent gives you contextual help. It's conversational. It's menuless.
And that relies on what? What are the core pillars of that?
It's really four things. First is natural language understanding, so it knows your intent. Second is context awareness, so it remembers the history of your conversation.
Yeah.
It knows what you asked for 5 minutes ago.
Okay, that makes sense.
The third is autonomous decision-making, and this is crucial. It means the agent can run a multi-step workflow, find the data, make the report, format it all without you telling it every single click.
And the fourth?
Continuous learning. The agent gets better and better based on your feedback and your behavior over time.
That completely shifts the cognitive load. So instead of me spending 3 minutes hunting through a dashboard for a report button, I can just say, conversationally, show me last quarter's sales figures for the US region.
And the agent just does it. This is already happening in powerful tools. Look at Microsoft Copilot. It writes emails. It arranges meetings, all from natural language. Or Notion AI, which helps generate content. Users are reporting a real, tangible 25% jump in task efficiency.
Because you're working at the speed of thought, not the speed of clicks.
Exactly. And even internally. The sources talk about these sophisticated HR bots, one was nicknamed Harry Botter, that give instant correct answers on things like PTO, benefits, company policies.
And it's always up to date because it's connected directly to the internal documents.
Right. It cuts out the whole tedious process of searching a manual or waiting for an HR person. It's just a fundamentally better employee experience.
Okay, we've established the enormous promise. $300 million in saving, 25% efficiency boosts, the end of the frustrating interface, that's the reward. Now, we have to pivot and confront the risk.
Right.
When an autonomous system designed to act starts browsing the open, untrusted web, what does that new threat landscape actually look like?
You're moving from a simple software vulnerability to really an existential security risk. When these browsing agents are out there, they're navigating untrusted websites, they're reading third-party content, and crucially, they're handling very sensitive data.
Login credentials, session tokens.
API keys, internal tokens, you name it. The second they step into that untrusted world, their attack surface just explodes.
So what's the one thing, the specific mechanism that decision makers should be most worried about right now?
Without a doubt, it's prompt injection. It's a critical severity risk because it means malicious content, say a single line of hidden HTML on a web page, can completely override the agent's core internal system instructions.
So it's basically a hijacking of its brain.
It is a mental hijacking. That's a perfect way to put it.
But how does that outside content manage to override the agent's, its core mission? Shouldn't those initial instructions always take priority?
You would think so, but
Yeah.
it comes down to this really fundamental architectural flaw in how large language models process long strings of text. It's often called the lost in the middle problem.
Loss in the middle.
Yeah. A case study on an open source agent called Browser Use showed this very clearly. The agent's design just appends the untrusted web content to the end of the LLM's prompt. Now, paradoxically, LLMs pay disproportionately high attention to the tokens at the very beginning and, crucially, the very end of a long prompt.
So the malicious code, because it's at the end, is essentially screaming louder than the original mission statement at the beginning.
It is screaming louder.
Yeah.
The architecture itself provides the perfect delivery mechanism for the attack. That malicious content isn't just data anymore. It's being read as a higher priority command.
And the result of that is?
The outcome is catastrophic. It's a credential exfiltration. The attacker injects a new system message that tells the LLM to just drop its original task. Then it instructs the agent to search the whole prompt context where it stored the user-sensitive tokens, maybe formatted like secret placeholder secret,
Oh, no.
and combine them and then send them out using one of the agent's own tools.
Yeah.
An email function, a malicious URL call. The agent is willingly, autonomously delivering its user secrets to the attacker.
That is insidious. The agent is weaponizing its own functionality against its user. Were there other systemic flaws found in that open source tool?
Yes, the study also disclosed a very serious domain restriction bypass vulnerability. It was assigned CVE 2025-47241. And this one allowed attackers to get around the agent's security that was supposed to stop it from going to unauthorized sites.
Oh, wait, so the agent has a firewall that says don't go to these internal domains. How did they trick it into violating its own rule?
They used a kind of camouflage. They exploited a flaw in how the domain parser worked by crafting a malicious URL with basic authentication fields. So something like https.example.com.pass at localhost.8080.
Ah, I see.
The security parser was fooled. It only looked at the example.com part, which was probably on the allowed list. But the actual network request went to localhost.8080, giving them access to internal services behind the firewall. It's a classic case of a security check failing because of an unexpected input format.
Okay, so if agents are this powerful, but also this fragile, we can't just stop using them, but we absolutely have to secure them. What does a robust defense actually look like?
It has to be a multi-layered, defense in-depth approach. Security experts use frameworks like Mistro to analyze risk across the entire stack, the model, the agent framework, the environment. And since prompt injection is a cross-layer threat, simple patches just aren't going to cut it.
Let's talk about architecture then. How do we mitigate that initial access? How do we stop the malicious content from hijacking the plan in the first place?
The leading strategy is what's called architectural isolation. So instead of one single LLM running the whole show, you disaggregate the agent into two separate parts.
Two parts.
Yeah. You have a planner, which is like the secured brain, does the high-level decision-making, but critically, it only gets trusted, sanitized inputs. Then you have an executor, which does the actual actions on all the data, trusted and untrusted. This separation means that junk from the web can never directly influence the planner's goals.
We're basically building a secure proxy inside the agent's own thought process. That makes a lot of sense. But what about stopping the harmful action, even if the plan somehow gets compromised for a second?
That's where you'd use formal security analyzers. Think of it like an AI watchdog that steps in right before the executor is about to act, like before it calls an API or clicks a link. It enforces hard constraints.
Like a rule that says what?
Like a rule that says, thou shalt not use data scraped from an untrusted external site in an internal email tool call. Period. This layer gives you strict, verifiable guarantees against unsafe behaviors that a compromised LLM might otherwise try to execute.
So that's prevention. But if we assume some exploits will get through, what about post-exploitation? How do you limit the damage?
Resilience is everything. You need something like an agent state reset or session isolation. If the system spots anything suspicious, a weird API call, too many high-value queries, it has to immediately wipe the agent's memory, start a fresh session. That limits the attacker's ability to dig in.
And what about controlling the data itself?
That's information flow control. These are policies that track where data comes from, its provenance. You create rules like data read from a private internal document is tagged as sensitive and is forbidden from ever being sent to an external URL. No matter what the agent's task is, even if the agent is compromised, the system enforces these data integrity rules from the outside.
This all sounds like a pretty heavy engineering lift, adding a lot of complexity for security. Is there an architectural shift that could make the agent inherently more reliable from the start?
Yes, and this actually links the security discussion right back to efficiency. We're seeing huge progress with something called Walt Web agents that learn tools.
Okay, Walt, what's the core idea?
The core idea is that standard agents, which learn these brittle sequences of actions, click here, type this, hover there, are slow and they break easily. Walt changes this by reverse engineering high-level callable tools directly from the website's own functionality.
So instead of clicking a button, the agent reverse engineers the API that the button calls.
Exactly. Instead of a multi-step UI dance to filter some listings,
Yeah.
Walt figures out, oh, this website uses the URL parameter sort price desk to sort. And then it creates a custom robust tool like sort listings parameter. It bypasses the flaky UI interaction entirely.
Which would make it much faster and less likely to fail.
Dramatically more robust and way faster. We're seeing 1.3 to 1.4 times faster execution. And these tool-based agents have near perfect success rates, like 98 to 100%, because they're using the stable underlying API the developer already built not the fragile front-end interface.
So wrapping this all up, what does this all mean for you, the learner? I mean, the tension here couldn't be clearer. This move to AI agents promises incredible efficiency, hyper-personalized experiences, conversational interfaces that, replace the tyranny of the menu bar.
It does. But getting to that future requires a complete break from our traditional security models.
It seems so.
Yeah, the key takeaway really is this. The promise of efficiency and personalization is real, and it's being delivered today by these autonomous agents. But that enormous benefit is only accessible if you accept the non-negotiable requirement of architecting strict, multi-layered security defenses, things like architectural isolation, formal analyzers, and these new robust paradigms like Walt directly into the agent's core, not just bolting them on later.
And finally, a provocative thought for you to mull over as you think about bringing these powerful systems into your own work. Given that this tech is designed for autonomous decision-making, and it's already handling high-value tasks like payment processing and HR policy, who bears the liability? Who bears the financial responsibility when a highly optimized, sophisticated AI agent is successfully hijacked by a single line of malicious text on some random web page?
Is it the developer? The platform provider? The business user who deployed it?
Exactly. The legal and insurance worlds have not solved that yet, but the technology is already operating at scale. Think about that as you continue your journey into agentic AI.